Alright, so today we're talking about domain and range in context. So again, your domain is referring to what? Your x's, and range talks about what? Your y's. So for these problems, it's going to be word problems, okay? And we're trying to figure out in this specific context what makes sense for your domain and range. So a lot of times your domain is going to be talking about time because that's your x value. So like 90% of the time, x is going to be time for you. And then like for the one that we're going to do next, your y is your height. So we'll go ahead and just do this because I think that's the easiest way to kind of understand it. You've got like a checklist up here at the top. So I want you to identify your function, which has been done for you in most of these. Then determine your variable for domain and range. Then decide the least and most for your domain, and then you'll plug those numbers into your function to get the least and most for your range. So I know that sounds a little weird right now, but we'll go through it in a second. Hopefully it won't be too bad. So Mark is punting a football with an initial velocity of 64 feet per second. The height h of the ball after t seconds is represented by this equation. So the graph of the function is shown right here. So we want to know a good estimate for the domain and range of your function. So our first thing is to identify your function. They did that for you right here. Yeah? Are we all good with that? Yes, no, maybe? Okay. So now we've got to decide which variable is going to be domain and which one will be range. So we're talking about height and seconds. So you got height h and t seconds. Those are our variables. So which one do you think would be domain?
The
T, because we said, remember, domain is like time. 90% of the time your domain is some measure of time. So your domain variable is going to be t. What's like the smallest amount of time that you think we could possibly have?
0.
0, right? So that would be your domain lower bound. And then your upper bound, if you look on your graph, can we tell where it looks like it's ending again? 1, 2, 3, 4, 5. Remember, domain is from left to right, so we're going from 0 to 6. Yeah, I think it looks like 6. I think for y'all were looking at the range. Y'all look at how high up it went. Remember, domain is left to right, so we're looking left to right there. I'm going to try to this out just a little bit. Give me a second, y'all. That's better. Okay, so when we write our domain, do you remember how we wrote it for graphs? When we had like the smallest number, we left some space, we wrote the biggest number, there was a chunk that we put in between. Do you remember what that was at all? Less than, we'll put t, because that's our variable this time, less than 6. Remember doing that?
Yep.
Yeah? Because you're doing it again. So we've got our domain, so now we can start talking about our range. So your range variable is not t seconds, but what? H for height. So what would have to be like our lowest possible height? What do you think? 0, right? We can't go negative. Do you agree? Because like if you kick a football and it hits the ground, is it going to hit the ground and keep going underground? No, right? It's just going to stop there. So it's not going to be anything negative. It would have to stop at 0. And then what about the upper bound for our range? What was the highest that it went? What is it? 100. And y'all, this one, I think it's much easier to just look at the graph because you have one than to worry about plugging in functions. For the next one, we don't have a graph, so we're going to have to plug stuff in there. But for this one, we can just look at your function and you're good to go. So then when we want to write our range, we'll say from 0, and we'll leave some space, then 100 on the other end. And what's that chunk that goes in between? Usually we do less than y less than, but what's our variable this time? So we'll put a less than h less than. Questions on that? Are we okay? All right, so let's look at the next one. So it says the girls' basketball team is having a fun. The girls will receive $20 plus 5 for each product P that they sell. What is a reasonable domain and range for this function if they are required to sell at least 5 items, but no more than 50 to earn anything? So the first thing we need to do is identify a function. Do they give us one? They did, but they didn't write it out for us, so we have to write it out. They tell you that they received $20 plus $5 for each product that they sell. So how can we write that? $5x plus 20 equals what? They use different variables, but it's okay. Do you understand where that stuff is coming from? Because they receive $20 plus 5 for each product that they sell. So that's your 5x. Are we all good with our function? All right, so then we can write that up here. Y equals 5x plus 20. So our domain is just our x's, right? What are like our number of items is what they said for this one? What? Domain is x. In this problem, that's like your number of items that you're selling, right? And then your y would be at how much money you made at the end. Does that make sense? So what was the smallest number of items that they're required to sell? So your smallest value for your domain is 5. Is that okay? What's the largest number of items that they're allowed to sell? So that's your largest value for your domain. Are we okay with that much? Yes or maybe? So how would we write our domain? Less than x less than what? 50. Do you have questions? All right. Oh, excuse me. So then we're talking about our range, which we said for this problem that your range is going to be how much money you made, right? Does that make sense? Okay. So do we know, do they just flat out say the least amount of money you can make is this, the most amount of money you can make is this? Do they say that? No. So how do you think we can figure it out? What do you mean stop it? Do we know the least amount of items that you could possibly sell? So could we take that number, plug it into your function, and figure out the least amount of money you could possibly make? Yeah. So we'll plug in a 5. So we'll have 5 times 5 plus 20. I'm going to write that right here so we know where it's coming from. And what is 5 times 5? And 25 plus 20 gives you 45. So if we found our least amount for a range by plugging in the domain least value, how are we going to find the greatest amount for a range? Exactly, plug in the greatest from your domain. So we'll plug in 50 this time. So we've got 5 times 50 plus 20. So 5 times 50 gives you what? 250 plus 20, 270. Then how would we write our range? Questions on that? So are we doing okay? Yeah? Alright, so we'll do a few more together. So the next one, Macy worked at a summer camp where she earned $20 plus $7 an hour each week. The amount of money she earned each week could be represented by this function right here for each hours worked. If Macy could not work more than 20 hours each week, what is a reasonable domain and range for the situation? They gave us our function, right? We've got that, so we're good to go there. Now we've got to decide what's your domain in this problem and what's your range. So what do we think? So we've got H and E. E is talking about how much money we earned. H is talking about hours. And we said that domain is usually what? Some measure of... The only person that knows is Rachel. Time, right? So which one is time? Money or hours? Hours. So that means that H has to be your domain. I'm going to write that on there because I think we're having a hard time remembering that. Domain is going to be time. So then we've got to decide our upper bound and our lower bound. So what's the smallest amount of time that you think they would probably let you work? 0, right? Could you work like -2 hours? No. It's got to be 0. So then what about your upper bound? What's the most amount of hours that they'll work?
Do what?
Your upper bound. What's the most hours they'll let you work? 20. So when we go write our domain, how are we going to write it? 0 less than 20. Are we okay with that? We're being like real quiet this morning. I don't know if we were just sleepy or if we were not understanding. Just tired. I get it. Me too.
Yes, Monday.
We still gotta learn things. Sorry about it. So our domain was H. What does that mean your range is gonna be? That's the only other variable we have there. E, right? So it's like how much you earned. So what's the least amount of money we could earn? Do we know? Did it tell you? Did they tell you?
No, you got plenty.
We got to plug it in and find it, just like we did before. So we're going to plug in our smallest domain value into our function. So you're plugging in a 0. So 7 times 0 gives you what? 0 plus 20? 20. So the least amount of money you can make is still $20. That's a pretty good job if you can not work at all and make 20 bucks. No. You work $0 and you get paid 20 bucks.
No. Yeah.
Right?
Yeah.
All right, so then what about the most amount of money you can make? How are we going to find that? Plug in 20. Yeah, so you're plugging in your upper bound. So 7 times 20, what do we get? 140 plus 20.
160.
So then we could write that 20 less than E and 160. Questions? Is it starting to make a little bit of sense? Like, I just honestly don't know how we're feeling right now. So I don't know if you need more help. We're all right. Okay, so the last one that we've got is as a fragile bacteria cell multiplies at a growth of B equals 2 to the S, that exponent is an S, where B is the number of bacteria cells and S is the number of seconds. So B is bacteria, S is the number of seconds. Which one's going to be our domain?
S.
So that means range has to be B. In a controlled environment, the scientists kill the bacteria off after 10 seconds. So what is a reasonable domain and range for the function? So we already said that our domain was S and that was seconds. So what's the smallest amount of time that we think we could put here?
10 or 0.
0, right? What about the largest? What's our biggest amount of time?
10.
Why is it 10?
Because, I don't know, it just, you have to cut the bacteria off at.
It cuts it off at 10. It's just saying we're done at 10 seconds. We're only letting this happen for 10 seconds, then we're done. So your upper bound's got to be 10 there. And how are we going to write it?
0 less than S less than.
Is that all right?
Yeah.
So then we got to talk about our range. And they don't tell us any of these things, but how could we figure it out? You could look at your graph. Or what can we do? I would just plug it in. I think that's going to be a little bit easier because this graph doesn't actually match our function. Your lower bound, if we plug in a 0, what is 2 to the 0 power?
2.
1. I don't know if I remember your exponent rules, but anything to the 0 power is 1. And if you don't believe me, type in your calculator. Type 2 to the 0 in your calculator. Tell me what you get.
What did you say?
2 to the 0 power. Type in your calculator.
Wait, don't say anything. Let me get it. 1.
Type 10 to the 0 power. Tell me what you get.
1.
Type 107 to the 0 power. What do you get?
1.
Type 1192
1.
to the 0 power. What do you get?
Oh.
1. Always 1, right?
1.
So then what about your range upper bound? How are we going to find that? Instead of plugging in 0, what are we going to plug in? 10. So 2 to the 10th. Type that in your calculator. Tell me what you get.
250.
1,024.
That's a lot of bacteria. No wonder they cut it off after 10 seconds. So then we just need to write it and we'll be all done. So for your lower bound, what are we going to put? 1 less than. Are we okay with that, y'all?
Yes.
Yeah? Y'all ready to try some on your own or not quite?
No.
Hold on, wait.
All right, well, just hang tight for a second. I'm going to give you the next page and we'll do something together.
Yeah, bro.
All right, so we'll do a couple of these together. Let's see which one. It'd be helpful if I was looking at the front of the page. We're definitely gonna do number 2 together. Number 4? Do we really do that one together? I think that's kind of easy. We'll do number 2 for sure. I want you to look at number 5. We'll do that one together real quick. Number 5. So the science class is launching rockets. The height h of a group or of group A's rocket after t seconds can be found using this function. So what's a reasonable domain and range for the situation? So what is your function that we're talking about?
Well,
That okay? They gave it to you, right?
Yes.
This is number 5. It's on the back. So then we've got to decide what's your domain, what's your range. So we're talking about a rocket's height after t seconds. Which one is going to be domain? T seconds, time, right? So I'm going to write that over here, t. And then your range is going to be what? H, your height. Did y'all kind of notice H is in the place that Y usually is? Yeah, that's why T is your domain and H matches your range. That's another way to think about it, okay?
It just all falls into place, man.
It's crazy how that works out. So your domain, can we tell your smallest amount of time? What's your smallest amount of time going to be?
0.
0, right? What about your largest amount of time? Do we know? We don't know. What did we do last time for one like this? It was like number 1 on your notes. And how did we figure out this stuff? What did we look at? The graph. Do you have a graph? So you need to get a graph, right? You're gonna use your calculator. Okay. So go to your home screen. So if you press the home button, and then we're gonna go over to the second block on the bottom. It's got that little U on it. Does anybody know what that little U is called?
And this person got on me for not knowing it. And I keep grinding my brain, but now I don't know anything.
Do I remember what it's called?
It's like
U-shaped graphs?
they all got different certain names, like the sweet line grass and the Z-looking ones. They all got different names, man.
That's called a parabola.
What?
Parabola. A parabola? That's what that's called. Y'all knew that. Anyway, you're gonna go there. That's gonna let you graph anything you want. So we're gonna type in our function, but your calculator doesn't recognize H's and T's. It only does X's and Y's. So you need to put X's in place of T. Is that okay? So just 54X minus 18X squared. Is that okay?
Yeah.
Huh?
Why is mine like Japanese?
If you don't have your calculator, you need them. So I recommend that you forget it. Once you get it typed in, hit enter, and it's going to graph it for you, and we should be able to tell your domain here now, right? So is our smallest value still 0? But then it goes all the way over to what? Where? 3. So that's your largest domain value. So we're going to have 0, leave some space, then a 3. What do we put in between? There you go. Is that okay? Yes, no, maybe? What questions do we have? Alright, so let's look at your range. Now, just think about this logically, right? We're talking about launching a rocket. So what's your smallest height going to be? 0, right? Because it's not going to start from below ground or anything crazy like that. So it's going to start at 0. And then how high up does it go? Can we see that? I'm going to show you a trick to help you find this. The highest point on a graph. What's like another word that you might use for that?
Peak.
And beyond.
Keep thinking. Brainstorm. What are other words that might mean the highest point on a graph?
Peak. That's the highest point on that one.
Oh, so it's an arrow.
Starts with an M.
There's not one.
Yes, there
Do it.
is.
No, not major.
The end of the graph.
What's like the opposite of minimum?
Oh, maximum.
Maximum. That's how you're going to find the highest point on your graph. Okay? So what you're going to do is you're going to hit menu. You're not going to have to do this again for a very long time. That's why we're working through this one together. You're hitting menu. Did you do that?
Yeah.
Menu. And we're going to go to analyze graph.
Are you eating plastic?
So that's option 6. And then what did we say we're looking for the highest point on the graph?
Maximum.
Maximum.
Well,
Menu. Analyze graph. So once you hit maximum, you've got like this little dotted line showing up, yeah? If you use the center of your calculator that's going to let you like scroll stuff around. You need to click somewhere on the left, scroll over, make sure you highlight your whole graph, and click somewhere on the right. Yes?
Oh, it went away.
How do you highlight?
It zooms out, and it shows you the highest that it goes.
I just totally click.
She just said 40.
You just highlight the whole graph? Or is it-
Click somewhere on the left,
Okay.
scroll over, click somewhere on the right,
Okay.
and then it's going to zoom out and it's going to show you the highest that it goes. Yeah?
Dude, somewhere on the left.
So the highest that it goes is what?
40.5.
40.5. So that's our highest range value. That's not how you write numbers. 40.5. And what goes in between?
Less than H less than.
Are we okay with that?
Yes, ma'am.
Do we have questions?
Yes, ma'am.
All right. I think y'all will be okay with the rest of them. I do want to go back and do number 2. We're going to do number 2 together and let's do the rest on your own. Is that okay?
Yes.
All right, so for number 2, it says a baseball tournament begins with 16 teams. Let me get this to focus a little bit. After each round, half the teams are eliminated. So the number of baseball teams remaining, T, is a function of the number of rounds played. R can be represented by this. That's your function, yes? So when it asks for function, what are we going to write?
16 times 1/2 x.
Equals 16.
1/2 to the x. So for our domain, let's see, what would be our, does it say x? It switched variables out, that's okay. What's our domain in this problem? Is it the number of teams remaining? Or is it the round? What do you think T probably stands for? Y. Or is it the number of rounds or number of teams? Your teams, right? So your range is going to be your number of teams. Number of teams. T-E-A-M-S. And then your domain is going to be your rounds. They switched the variable out in the function when they wrote it, but that X is like your R. So what's the smallest number of rounds that we could have? Just think about it logically. 0, right? Do they tell you how many rounds they're going to have in this tournament? They don't say anything, so we kind of have to figure that out, right? So the first round, how many teams are playing? 16. Then after that round, how many teams get out?
8.
Half of them, right? So how many are going to be left?
8.
8. Then they'll play again, and how many will be left after that? Then they'll play again, and how many will be left? Will they play again after this one?
Yes. Yeah.
How many teams will be left after this round?
2. 1. After that.
Just one. So the one team's going to play by itself?
Yeah.
Of course. It's like,
No, they won. It's over.
they play against 8 of that.
So how many rounds does that take?
4.
4. So that's your highest domain, yeah? So 0 to 4 for your domain?
Go back to 4. What?
Which I guess really, actually, let's not write it like this. I lied. I don't want to write it like that. You could have 1 round, 2 round, 3 rounds, or 4 rounds, right? That's what we said. 1, 2, 3, or 4. Yeah? Does that make any sense? This one's different from all the others, so that's why we're doing it together. So then your range is your number of teams. So in the first round, what was our number of teams? 16. Did we have 15? Could you have 14? Could you have 13? 12? 11? 10, 9, 8.
Yeah.
So the next number for your range has got to be 8. Do you get what I'm saying? So it's not going to be all the numbers in between 16 and 2, but just 16, 8. What else? 4 and 2. And that's because you have that many teams get out. So this one's a different function. It's kind of different in this situation that you're in. Do we have questions on this one? So this one's weird because it's talking about the number of teams and rounds of your tournament or whatever. So other stuff that we've been talking about, like your height after however many seconds. Does your height always have to be a whole number? Can it only be 2 feet or 4 feet or 8 feet or 16 feet? It can be anything, right? It's a continuous function. So same idea with your time, right? You don't have to have just 1 second or just 2 seconds or just 3 seconds. It could be everything in between that as well. Do you kind of get what I'm saying? So that's why you've got inequalities for these, but not for the other one that we just did. Where is it? This one. This is the only one that's like that on here, so you don't have to worry about doing that again. Good? Do we need to do any more together before I turn you loose?
Yes, we need to do 1, 4.
Pick one. Pick one and one only.
7.
I wouldn't do number because that one's too easy.
12.
Doesn't go to 12. We can do number 6 because I heard 6. So it says a taxi company charges a $5 fee plus 10 cents per mile, and no trip can be more than 20 miles. The cost C for AM miles in a taxi is represented by your function right here. What is a reasonable domain and range for your situation? So when it asks us for our function, what are we going to put?
C equals 5 plus 0.1.
5 plus 0.1 m. That okay? So what's being our domain, or like our x in this problem? Somebody said it. M, miles. And what's being our range, or like your y? C, which is your cost. So what's the smallest amount of miles that you're going to go? Okay, does it tell you the biggest amount of miles that we can go?
20.
So what goes in between?
Less than or greater
Less.
equal to.
I don't care if you put equal to on there or not. That's totally up to you. But you got to have less than and less than. So then how are we going to find our range? Plug those in. So if we plug in a 0 up here, what's 0.1 times 0?
0.
And 0 plus 5? 5. So they're going to charge you for $5 just for getting the taxi. Even if you don't go anywhere, they're going to charge you $5, right? So then, how are we going to find the most that they would charge you? Plug in 20. So 0.1 times 20. Do y'all know the easy way to do that? Move your decimal. 1 place over. 2. So that's 0.1 times 20 is 2. Plus 5 gives you 7. What goes in between?
Less than.
Questions on that? Do it? Yep, that's number 6. Are we alright?
I think we're ready for that.
Yeah? Okay, so try the rest of them on your own.
Can we talk with people at the table?
Yes.
Ready.